All right, we're back. We are MAPD724. That's Advanced iOS Programming at Centennial in the winter 2018 semester. And we are week 1, part 3 of our broadcast. We just started talking about assignment number 1. A couple of thoughts for assignment number 1 before I continue is think about also deploying it to a device. You should check it on a device. We have devices here you can test with. I also didn't talk about things like landscape and portrait. I didn't talk about that. I didn't talk about iPad. There's a lot of different things you can do. You have a lot of leeway on this one in terms of whatever your design is going to be. So think about those things before you decide what to do. All right. So the rest of this whole part here talks about resizable image, but I want to talk about graphics contexts right now. And the reason why I'm opening up with graphics context and images and stuff, because you need them for your app. Next week, we're going to be talking about Sprite Kit. Okay, that's not in your book, 100%. So I'll be talking about how to put together a small game with Sprite Kit. I might spend a week or 2 on it because the next app you're making is a shooter, some kind of space game, okay, on your little iPhone, okay? Why am I doing that? Because games, right, are one of the #1 apps that make you money on iOS, right? In fact, games make more money on iOS than they do on Android, right? So I want you to have a chance to make money, right? Maybe you have a game idea. Maybe it's a simple idea. Maybe it's a game for your, for a special occasion or something. Or maybe a company's going to hire you up because they want a special ad that's a game. They want your users to play a little game and then get some information or win a coupon or something. It's done less and less now. It's usually not like that, but we're going to practice. And I don't expect you guys to know anything about game making. Okay, so don't worry. If you're not a gamer or you're not a game player, it's okay. You can think about simple ways of making things fun. Okay, we're not talking about first-person shooter. Okay, we're not going to make that kind of game. We're not going to make any killing games. Okay, it's going to no snipering. We're just going to avoid problems. Okay, we're going to avoid stuff. So public service announcement: don't kill anybody. All right. Graphics contests. Okay, so the graphic context, really what you think about is like, I want you to think about is where you can draw. Okay, so a graphic context is almost like a container. All right, so where can you draw your stuff? That's what a graphics contest is. And there's different ones. I don't know why this keeps flickering, but you can create an image context. Coco can create one for you. I mean, there's different ways of passing a graphics context to you, depending on how you work. On the web, the graphics, there's 2 main graphics contexts on the web, which is Canvas, right? You want to make 2D context or 3D context with WebGL, okay, on the web. Here, again, there's 2 different ways you can do games on iOS. You can use Sprite Kit later on, or Scene Kit. Sprite Kit's 2D, Scene Kit's 3D, and you can also use Metal, which is almost like a 3D context where you can tap into the GPU of your device to really get some good performance. Metal is unfortunately out of context because that is like you and I are going to be playing games all semester then. That's how difficult it is, all right? And so is Scene Kit. We're not going to make a 3D game this semester, okay? We don't have time. However, we can make a 2D game. 2D games aren't that difficult, and Sprite Kit allows us to do this. But before we do that, we need to understand a little bit about graphic context. All right, so the idea that when you draw, whenever you use the UI views draw function, right, a context is created for you. And there's something else called a CA layer, which we're not going to get into right now. Okay. So there's different ways of drawing. You can use something called core graphics, and core graphics creates something called a CG context. Now we're going to use core graphics for different things. A CG point. CG point. You're going to hear about that when we get into making some games. Okay. So here's an example of a graphic context. I'm going to override the draw function that's built in. Notice that I'm going to make a CG rect. A CG rect is what it's listening for, right? A rect is a rectangle. Okay, so some kind of square or rectangle shape. And that's what this function is listening for. And I'm saying, well, let P be some kind of Bezier path. This is interesting, right? Inside of a rectangle. So here's my border, right? I'm making some kind of oval. I'm going to draw a circle inside of a rectangle here. That's what I'm doing, right? With my color as the color fill as blue. Okay, that's pretty interesting. And I'm going to fill that path, that Bezier path, with blue. Now, sometimes people call this Bezier, a Bezier curve, right? Depending on who you talk to. I like calling it Bezier, but there's two different kinds of curves that are very popular. There's a Catmull-Rom kind of curve and a Bezier curve. And if I was going to show you what that looks like from a graphics perspective, by the way, guys and girls, this is Graphics 101. All right, so if I look at a Bezier curve, see what that looks like. That's what it looks like. And you can see some of this stuff where you have these two handles, right? And in something like Illustrator or Photoshop, you can make the curve by changing the handles, right? A Bezier curve when you create this path, right? That's one type of curve. And there's also something called Catmull-Rom, right? So Catmull-Rom curve, right? Or spline, if you will, looks like this, where you have a Catmull-Rom curve and you have 4 points. And then you decide, these 4 points decide this curve right here. From point P1 to P2, you need point P0, P1, P2, and P3. And then there's a special algorithm, right, with a matrix mathematics that you can do to create this little curve. Am I going to ask you to do that? No. I just want you to understand that this is a curve or a spline. Okay, that's what it's called. So here back in code, we're saying, hey, I want to make some kind of curve, right? And it's going to be inside of this rectangle. Notice that the rectangle is X and Y. So 0, 0 is the X and Y coordinates of the rectangle. And the width and the height. So some kind of rectangle that is 100 by 100, and that kind of rectangle is a square. If I have a square, right? Starting at the 0, 0 point at the origin, and 100 by 100, guess what kind of curve I'm going to get, right? If I'm doing a Bezier path, right, I'm going to get some kind of blue curve in there. All right. So that's what this does. That's what this functionality does here. And it creates a graphic context automatically for us, right? Core Graphics does it a little differently. So notice this isn't using Core Graphics. This is overriding the UI views draw function, okay? The other way to do it is to override the draw function and use a CG rect with the Core Graphics. This is the Core Graphics way of doing it. Here, we let the context, we create our context. So this is the place we're going to draw stuff. And we call it UI graphics get current context. We get the current context of the for the graphics. Then what we're going to do is we're going to take that context and we can add an ellipse. This is using Core Graphics to do the same thing. We're going to add an ellipse inside of a container in this CG rect, and we're going to fill the color with blue. Same thing. One is using a UI view. One is using Core Graphics. We're going to be using Core Graphics a lot. Okay, so I want to show you different ways of doing the same thing. So in our context, we use something called Quartz 2D. Quartz 2D is almost like a framework that's inside of that's used by iOS developers to create graphics applications with Core Graphics. Okay, so really what Quartz 2D does is it gives us the view or the image that's being drawn, right, in some kind of canvas. And I want you to think about the canvas just like it is in HTML. Did you guys do any canvas in HTML? So the HTML canvas, or even this canvas, I want you to think about it as a dry erase board, right? This dry erase board here, right? So if I draw something, what am I really doing? I'm filling in the pixels. We talked about the previous video. We talked about the pixels. Each pixel has color and position. So if I draw something, if I make some kind of line on the canvas, I'm just populating the pixels with data. I'm saying this pixel has this color, this pixel has this color, and there's a bunch of pixels that get filled up, right? But guess what? If I don't touch that canvas again, if I don't update that canvas, the pixels are always going to be there, right? If I want to take those pixels and move them around to create animation, I've got to wipe the dry erase board and redraw it again. I got to wipe it again and redraw it again. I got to wipe it again and redraw it again. And I got to do that several times per second. For a game, typically we redraw things 60 times per second. Each time we draw, each instance of time that we draw is called a frame, right? So usually we draw in 60 frames per second. We erase everything and redraw everything 60 times every second, which is approximately every 16.66 milliseconds, right? That's how the canvas works. Now, you can set the refresh rate of your canvas to different values, okay? For us, we don't have to worry about that. But I want you to think about that as this virtual canvas that we're going to draw on, okay? So again, what a painter does is he paints the entire canvas red, all right? And then he paints the bottom half of the canvas blue. And then, you know, he adds some other colors. So in real life, right, we have some kind of additive colors where we add colors together. You know, we mix colors together in real life, blend them together to get a color, right? And the way color works in real life is, you know, it reflects some kind of color, reflects that part of light, right? So light has a big factor in this, right? That's not how pixels work. Pixels don't work like that. You don't blend pixels together to get a color. It's not like that, right? We can simulate that, right? But really what we do is we add the values of the pixels. So for example, I have a color of 120, whatever that color is in the red spectrum. And I add another on the blue channel, I add 50. And then I add some other color on the green channel that's 30. And I get some other random color, whatever. Those three color channels overlap each other. They blend. And we get the final color, right? So it's a little different when it comes from a, you know, real life to what happens in, you know, on the screen. So one thing that the Quartz 2D does, it provides things like lines, shapes, image drawing functions, and all that kind of stuff. The only limited thing is it does 2D drawing. It doesn't do 3D drawing. For 3D stuff, we use a 3D application, okay, typically, okay? So I wouldn't want to randomly generate something in 3D typically unless I had all my points. And even then, it's a pain in the ass. So you use an application like Blender, right, which is an open source application. So if I was going to do something in 3D, I can use an open source application like Blender as an example, where I can modify my shape, you know, in Blender as an example, or Maya, or 3D Studio Max, or one of those complicated professional applications where I can kind of go into the application itself, you know, as an example, and modify things like each of the vertices to create, you know, the shape. I can deform my mesh. Think about this as a mesh of data, right? And I have vertices, edges, and faces in 3D, and I can modify stuff. Again, beyond the scope of this course. Nice. I like it. No time, right? So we can't talk about it, right? But I want you to say this is not the same thing as drawing. So when we draw on a canvas, we don't draw 3D shapes. We draw, my watch is telling me it's time for bed. I don't know why. You know, we draw on a 2D canvas, and a 2D canvas is like some kind of paint, like some kind of canvas we're going to paint on. All right. So it's not 3D like this. And when it says lines and shapes, think about the lines I'm going to draw. I have a pen, and what I'm going to do is I'm going to say, hey, I want you to move the pen here. When I move the pen here, I want you to draw from here to here with this color. Okay, now I want you to move from here to here, draw in this color. Now I want you to move from here to here and draw in this color. Then I want you to fill in this shape. And now I want you to fill in that whole shape with some other color, right? That's how drawing works. And it's so slow. It's like you have to literally draw everything. Do I expect you to do that for your slot machine application? No. You have to understand how drawing works. That's all I want you to understand, right? All right, so we have this draw function like we talked about before. That's what's going to be the meat and bones of our application, right? And we use this core graphics, and we use the current context. We talk about all this stuff, right? And this is what we kind of say that something like, okay, we want to get the current context. So we're going to say, hey, when we use our, you know, in core graphics, we want to get access or a reference to the current context, where we're going to start drawing. And then what we're going to do is we're going to start, and by the way, one thing to note is that, and like it says here, this is very interesting, that it uses low-level C language calls. Okay? So it doesn't use Swift for this. Okay, it goes right down to the sea level. I like to say that because like the sea level, right? And the reason why is because this is how complex it can be. It writes its own, it uses shader data in 2D to kind of create its language. It has its own API. Now, we're not going to use it at that level. We're going to use the high level API, which is the core graphics API. But if you wanted to, you could program everything with C++ on your iPhone if you really want to. It's crazy, but you could do it, right? And it would probably take you twice as long or 3 times as long. So here's some examples of this. So I have my core context, and then I set the line width to 4.0. That's the width in pixels or in points, if you will, right? I can also set the stroke color. By the way, this is almost identical to what we do on the web. If you actually do anything with HTML Canvas, almost identical to this. Almost identical, right? So I set the stroke color, what the stroke color is to a particular color, and then I move. So at first I set my line width, and then I move to a particular place. I move to, let's say, 1010, and then I add line, right? I add a line to another position at 2020. So from 1010, bottom left corner, to 2020, I make a diagonal line. That's what I'm doing here. And then when I say stroke path, it means draw it. That's what this thing does. So first I get the context. Where am I drawing? And then I set some stuff up, the line width and the color. And then I move my pen from one place to the other, and then I decide to create the stroke, right, to create that line. So again, it's not that difficult to understand when you look at it. But if you've never seen it before, it's like, holy crap, I have to do all that work just to draw a line? Yeah. That's what it does in the background. So when you see apps drawing stuff for you, a lot of draw functions or draw calls are happening in the background. You don't know what's happening. These things are happening. Typically, the way it works like this, Quartz 2D. Okay, here's Quartz 2D. And what it has is, it's the 0, 0 point for Quartz 2D is in the top left corner of the screen. Okay? And this is very interesting. So if I draw from 1010 to 2020, I draw a diagonal line like this. 1010 to 2020. Now, for people who've never done graphics before, typically you're used to, Cartesian math, right? Geometry and math starts off the bottom left-hand corner of this thing. So bottom left-hand is 0, 0. Not so. But that means that as I march across this way, I'm increasing my x component. My x component increases as I go to the right. Now, this is weird. When I go down, right, my y component increases. Down is positive for y, right? And this is where sometimes people can confuse because you want to go up with y. But up means this way, down, right? And why is that? Because I draw this way, width, and then I draw my height. I'm drawing something. It's like, here's each of these pixels, right? And then I draw in rows and columns, and I keep drawing. Notice I'm going down because I'm adding to my texture. I keep adding to it, and it goes down, down, down. So as I'm drawing more text, more pixels, I move down on the y-axis. That's y positive. Now that's different than the OpenGL context. If you're somebody who's used to drawing things with OpenGL or regular math, it's this way, where 0, 0 is the bottom left-hand corner. Okay? Quartz 2D is not like that. The Quartz coordinate system is opposite. Well, not really opposite, but it's top left as opposed to bottom left. All right? So OpenGL starts down here on the bottom left corner, and then notice the line would be different in OpenGL. OpenGL is open graphics language, right? It's an open source way of manipulating graphics. And by the way, you can use OpenGL with the iPhone. You can do it with the Android phone, because if I have a screen, most phones I can program with OpenGL. And in fact, other programs like Unity and Unreal and other kinds of game making software uses OpenGL one way or the other. Okay, so we talked about the coordinate system. We also know that there's 2 floating point numbers, which create something called a CG point in Swift, right? CG point, which is core graphics point, X and Y. That's what it is, right? So a floating point value for X and Y. That's what it is. And a CG size, right? So Quartz uses CG size, which is a struct. Remember the difference between a struct and a class? A struct is almost like it's something that has properties typically, but doesn't have any methods typically. All right. So a struct could be something like an integer. That's a good example of a structure, right? And more primitive structures only have very simple values, right? Now, in more complex programs like C++, languages, C++, and in C#, structs are viewed differently. And we talked about that, where in C#, structs are what? They're value types. And classes are reference types, right? And in C++, they're both reference types, but one defaults to public and the other one defaults to private. So classes are private in C++ and structs are public. That's the difference. Swift is the same. Okay. So when it comes down to it, I want you to think about CG size as some kind of object that has two floating point values, width and height. It's interesting, but it's very similar to CG point, right? CG point has two floating point values, X and Y, right? CG size is like a point, but has two different properties. They're just named width and height as opposed to X and Y, right? In most programs, a lot of times we use a vector to describe these two things. And there's different kinds of vector. Vector 2 and a vector 3. A vector 2 is X and Y, and a vector 3 is X, Y, and Z. Typically, we don't need X, Y, and Z in a 2D context because we only care about X and Y. However, you may see vectors someplace where they have X, Y, and Z to define colors. RGB, X, Y, Z, doesn't matter, same thing, okay? Remember that colors are just data. You can also use a vector 4 to define a color. Why? X, Y, Z, and A, alpha, for alpha transparency. So there's 4 values for color, right? A, B, so RGBA, 4, right? A vector 4. All right. So here's an example. I've got my starting point. I'm defining this in Swift. Now I'm not doing code with you today because I got to talk about stuff. If you've never done graphics before, you're like, and if I do it, you might get it, but you may not. That's why I'm talking to you. I don't want to bore you, but I got to talk about this first, right? So I'm making a CG point here. Notice my CG point. That's the starting point, and it's at 1, 1 in this particular case. Okay. Quiz. I just told you about the coordinate system. Where's 1, 1 in Quartz 2D? Where is it? Don't look at the code. Don't look at your thing. You have to memorize this. Where is it? Top left, closer to the top left, right? So somewhere 1, 1, right? Some people think about 1, 1. Wrong. It's 1, 1. 1 across, 1 down. All right. Size of rect, another variable. I'm using the CG size structure, right? With a width and a height. Width of 10 units, height of 10 units. Okay, here's a rectangle, CG rect, where I have my origin. My origin is a point, right? And my size is of type CG size. So I'm using 2 different structures here, okay? So my rectangle needs both a point, CG point, and a CG size type of structure to make the rectangle. Okay, again, why am I showing you this? I don't want you to be surprised when you see it. We're gonna talk about this a lot, and notice that there's 98 slides we're not going to get through today, right? But I want to talk about them because so you understand how graphics work. Same thing with colors. So once we talk about the context, we can talk about the CG color, and the CG color allows us to draw different colors of red, green, blue, and alpha. Okay. Now, interestingly enough, each one of the CG colors are broken up into CG floats. Okay, why not just floats? You can make other kinds of floats too. Why not floats? Why CG floats? But why? Why not use just regular floats? Why is it not the same? It's a float. What's the difference? Float is a single precision decimal typically, right? So why CG float and not float? It's not the same, you're right, but why? Doesn't guarantee that a float on different devices is the same, because a float on an iPhone 4 might be slightly different precision-wise than an iPhone 6, but a CG float is always the same. So they have a standard. And by the way, this is very common. You might see, instead of using a regular float in computer graphics, you're going to use a CG float. And notice the values are between 0 and 1. Anytime you have something between 0 and 1, it's clamped. It's usually clamped between 0 and 1, where the minimum value is 0 and the maximum value is 1, right? And that's called normalization. We normalize the value between 0 and 1. So example, if I have a 255 colors for green and red and blue, each of them, right? And I have a value of 0.8 for red. What does that work out to in from 0 to 255? How do you figure that out? It's 80%, right? So you say 0.8 times 255, and that's your color value, right? So example, if I have a red, green, and blue value of 0.3, 0.5, and 0.7, right? So if I go to my calculator, right? If I say 0.3 times 255, I'm going to get a value of 76. That's going to be the red value. So that's how much saturation, red saturation I have. The higher the value, we can say that there's more red is saturated, there's more red saturation, right? And the less value, there's lower saturation, lower red, right? Lower amounts of red, okay? So when we have these normalized color values between 0 and 1, we use it because it's easier, because they're floating point numbers between 0 and 1. Whereas 0 and 255, then it doesn't make any sense, right? And also, I can use X, Y, and Z, right? X, Y, and Z are vectors. Vector, if I want to do different vector calculations. If I want to do lerping, linear interpolation between one color and another, it's much easier to use a color between 0.8 and 0.9, some kind of average or whatever with a T value, as opposed to, okay, a color between 123 and, 240. It's different. So it's much easier from a computer perspective to figure that out. So there's your mix, right? You got this R, G, and B, and you've got this additive, kind of color. Whereas in the real world, it's more subtractive if you think about it, right? So we have additive color. So when we have red and blue mixed together, we have this kind of magenta kind of color. When we have green and blue, we have cyan, right? And we have red and green, we get yellow, okay? And then with the white in the middle, right? That's really how we do the color model, right? And when we have nothing, we have none of these colors, it's black. So all the colors turned on is white, all the colors turned off is black, okay? Again, this is just like basic color theory. Hopefully some of you already know this. I hope you do. Again, alpha values is from 0 to 1, where 1 is 100%. Just like if I had a red color from 0 to 1, where red was 1, it would be 100% red, right? Which means the value would be, in RGB, 255, okay? So different kinds of color models. There's also another color model called Hsv and Hsl. Those are different color models. So hue, saturation, and value, or hue, saturation, and lightness. That's also very commonly used, especially when it comes to images, right? Like, so if I'm doing some kind of photography, and usually I use cyan, magenta, yellow, and black, so CMYK, when it comes to print. If I want to make a big poster, because the way machines work, remember, it's subtractive color and there's some additive color. You can't use RGB. RGB doesn't make sense. Use CMYK color. And there's a difference in the way you mix a color in real life, because in real life you have a canvas. You actually have a background. So if my canvas is white and if I put red on it, it's going to be instantly brighter, more white than red, right? I can't just put red, like pure red on white. It's going to be actually closer pink if I do that, right? So I have to adjust the colors when I print stuff in real life, right? And that's why I can't do it the way that we normally think we do it. If I put my red color on yellow, imagine if I had yellow paper and I put red on it. It's going to mix. It's going to create another color, right? Because there is no zero colors. And there's no transparent color in real life. unless you put it on some kind of glass, right? So typically we have CMYK for print, and also we have grayscale. So you can convert color to grayscale. And the way to do that is to remove R, G, and B, right? You remove the color, you strip it out, and you don't have any color value for R, G, and B whatsoever. There's no saturation whatsoever, but you still keep the color value. And then you mix those color values together. So for example, if I have brighter colors, brighter colors, that means I'm going to get closer to white. And if I have darker colors, like darker blues and greens, I'll get closer to black, right? And in fact, like I told you before, everything is really grayscale. And then when you put the grayscale value inside of, if I have one channel, only one channel, right? And I put it inside my, if I don't use any color, no red, no green, no blue, and I have one channel, it's going to be gray. Okay. Any questions around that? Because I don't want to confuse anybody. I know I talked about colors and pixels today and a bunch of stuff, but before you make any kind of game in real life, you need to understand basic stuff. So we're going to have like one lesson about this stuff, so you understand color theory and some simple things. All right, so again, we can draw images with quartz, right? And we're going to still use UI Kit and with core graphics. So imagine if I want to make an image, I can kind of make my image. I can create an image, right? So it's assuming this exists and points at a UI image instance. Here's my image. I can draw a point, right? So my draw point is 100, 100, and I can actually draw on the image. Okay. We have an example of that right now. Let's try it. So remember, I went back. I'm going to go back to my Xcode, and I have this image. Let's make it a little bigger, right? So I'm going to make it so that we can actually see the image. So instead of aspect fit, we're going to go to scale to fill. And we're going to make it so that it's the right aspect ratio like we talked about before. Remember that this was at 2500 by 1400. So we're going to make it 250 by 140 or something like that. Try this out. So we can go back to our numbers. So 250 and 125 is 375. 140 and 70 is 210. This should be 210. And now that's correctly aligned. That's scaled properly. So that's our image, right? And notice that the image is inside of the view, okay? So I want to access the image, right? Because this image here, notice that I want to get a reference to the image. Now, how would you do it? I have an image. It's a UI view. I want to get a reference to it. What do I do? Come on. The same as every other thing that I'm getting. I'm on an outlet, right? I'm going to get a reference to anything I want to reference on. I can create an outlet. You guys know how to do this already, right? So I'm going to go to here. I know it's boring to watch, guys, and I do apologize, but I need to show you, right? All right, so I got this, and I've got some ugly stuff in here I'm going to get rid of. I don't care about this stuff, right? Did I kill something? I think I killed something. No, I'm good. And I don't care about receiving memory warnings for now, so let's get rid of this. We don't care about this right now, so let's get rid of this. Give me some more room. And I want to create this outlet for this image, right? I don't care what it looks like right now. It needs to be aligned. I need to put some constraints on there or whatever, right? But I don't care. I just want to make sure I can get some stuff. I'm going to control drag into the class. And let's just call this beach image. Right? And it's going to be an outlet, and it's going to be of type UI image view, and I'm going to click connect. There we go. All right, so this is my beach image, like we talked about, right? Okay, let's go back to the code. So it says, well, I can get a reference to the image. This is the image, right? Well, this is my image right here. This is my beach image, right? So it's my image view. Now notice, this is a UI image, right? This is a UI image view. Are they the same? What can I do with a UI image view? Well, I know that if I create some kind of function, so let's say in my view did load, I can say something like, well, okay, my view loads, and I can look at my beach image. It's not the right place to do it, but let's just do it anyway. So here's my beach image dot And I can see that if I want the image itself that's loaded, this is the image. And if you notice, it's of type UI image, right? This one here, right? So beach image image means the image that's inside of my UI image view, right? That's what I'm referencing right now, okay? So I'm kind of doing this, right? And if I really want to, I can say that, I can define that as like var, my image, or let's call it image, right, is equal to, and which is of type UI image, by the way, is this. I can kind of do that, right? Because this is the same. This is a UI image, right? And this is a UI image. But okay, what's the problem? Here's my UI image, and here's my thing, and it says value optional type. Well, I got to fix it because I don't know if I'm ever going to get there. So let's explicitly unwrap. At the end of the day, okay, this is never used, but I have a reference to my image now. Yay. Okay, once I have a reference to an image, I have a context. Remember I talked about there's two ways of getting a context, through the UI kit and through CG, core graphics, okay? So if I say, well, I want to draw on the image, right? I know that the image itself is, some value, right? So let's go back. And if I click on the image, you can see that my image is 375 by 210. That means I have a local coordinate space, okay? I have a global coordinate space. My global coordinate space is my entire viewport. My local coordinate space is inside of my image. That's a container too, right? So, because remember, it's just a view. Every view is a container. So because this coordinate space is 375 by 210, that means I count 375 pixels to the right, and 210 pixels down. That's my coordinate space. Okay, so I want to be somewhere in the middle, right? So if I said something like, well, I want to be in the middle of my coordinate space, I could say, if I didn't want to calculate, if I just want to say what it is, I could say, well, I want to say 375 divided by 2, which is roughly 187.5, right? That's where I want my middle point to be. I want to kind of put it in the middle, right? So instead of my draw point, I'm going to draw this point, right? So let's just do this again. So let draw point is equal to a CG point, right? CG point is a point of X and Y, right? And I want to say that my X value, right, is going to be, what did I say before? I have a thing, 76.5? No, I was wrong. What do we say? 170, what? 187.5? Okay, sure. We can't put 0.5 necessarily, but let's make it 187. Okay, we can probably put 0.5, but I don't want to. And let's put the other one. So now that's one aspect, and the other aspect is 210. Well, it's easy. That's 105, right? So we'll say 105 is the X and Y coordinates of my draw point. Yeah? Okay, so we've got where I want to draw my point. It's going to be in this picture somewhere, and let's make it a color that we can tell what it is, right? All right, so we got my point, and it looks like, well, I want to image.draw at point. So let's see if I can do that. So I want to say, so image.draw, right, at CG point. There it is. And my CG point is going to be my draw point. Oops, if I can actually cut and paste. There we go. So that's where it's going to draw this. But what color is it going to be? Did I specify? No. Unless I specify, there's no color, right? It's going to be black, probably, right? My bet is it's going to be black, okay? So I'm telling it to draw. It says variable image was never, look what it says here. Okay, the image variable was never mutated. Consider using a let. Okay, sure. We can say a let. That's what it's telling us to do because it's safer to do than using a var. All right, are we going to see a noticeable difference? You're going to see, we don't know how big this point is. We have nothing. It's just a point. Boop, 1 pixel. We're changing. We have no knowledge of how big it is or what color it is, right? Let's run it. See what happens. And see if it even builds. And what we get on the simulator. Now we're doing this in view did load. So we're assuming the image is loaded. And then as soon as the image loads, we're going to actually populate something in here. All right. All right, so it runs. And let's see if we get more image. And I can't see it because it's way up here. It's still loading. Is it still loading? All right, cool. Well, why I don't see an image, man. Where is this thing? How come I'm not seeing it? Way in here. That's right. Something like right in the middle somewhere. Huh? It's a shell, right? You can't tell, right? Because we really haven't given any size at all, and we haven't given it any other thing. Okay. Well, all we've done is we drew this point. We draw a point at whatever we want, right? This little point. Okay. Didn't give us an error though, which is good. It's a good sign. That means it's trying to draw what we try to do what we tell it to do. Okay. Okay. We're going to get more complex now. All right. So if this is the starting point, here's the starting point. And I want to draw, I have a context, right? And I have a size. Remember what we can do? We can talk about the size instead of like now this is CG. This is core graphics. What we used before was the what should we call it? The point where I want to decide on a. I'm going to go to the top here to give you an example. We talked about one way of doing it, which is right here. And notice that we said that, okay, I want to have my UI, I want to set my UI color.blue.setFill to something else, right? UI color.blue.setFill. And then I can fill if I want to. That's another thing I can do, right? With my draw function. Let's see if I can do that. UI color, UI color.fill. Before I draw, I want to set my UI color, right? And then dot blue. We'll make it, so now instead of blue, make it orange. There it is. And then dot fill. And set fill. Sorry, set fill. Set fill. Actually, set stroke. How about that? Set stroke. Right? And then we'll draw. Will that make a difference? Let's see. So I'll run it. And we haven't set the stroke size or anything like that. We just make it, we made it so the stroke is orange. Now, I don't know if we can see it in this picture because it's still going to be pretty hard to see because of what it is, right? Right. I don't know if we can see it. It's kind of hard. Let's see if we can really make it bigger. Let's see if we can. I don't think we can. I don't even think we can see it. All right. So we can't see that. And let's see if we can make it our stroke size, right? Because one thing we can do is we can set our stroke size, UI. So my stroke size is going to be a certain path too, right? Now, this is just using this thing. I'm trying to draw inside of the image, which is kind of weird, right? I got an image. I got a reference to an image. I'm trying to draw. Okay, so guys, so how do I do the stroke size? So image dot, if I typing stroke, can I do something like this? No. Image dot draw, right? How about dot, if I put this dot draw dot something, like if I go, okay, I want to draw at this point and I want to do something else. Can I add something else at the end of this? And the answer is no, right? So I got to be able to set the stroke size somehow, right? Here's my point. How about my canvas? Can I do something with my canvas is my context, right? Here's my image. And if can I set the stroke size something like that? Set, I can't do that. So how do I do that? I can check if it's a resizable image. I can do other things with the image, right? I can draw with it. Here's my blend mode, right? I can flip the image if I want to, right? I can talk about the trait collection. I can rescale the image, resize the image, right? But it's not, immediately observable what I can do with this thing, okay? Okay, so what if I don't do this, right? What if I don't do this and I want to use CG core graphics? Okay. So how do I do that? So let's get rid of this, and I'll get rid of this reference because I don't care about the image anymore, right? And I want to use core graphics, so I have to import something else. I can't just import UI kit. So I'm going to import, and I want to say core graphics, right? So there's my core graphics. So before I use core graphics, I got to import it. Okay. Okay. So we'll do it inside my view did load, and now we'll follow the instructions that it has for us further down. So after we do this, you know, we did this stuff here with our other context, but now we're going to try it with core graphics. All right, so now I'm going to see if I can copy this stuff here and see what it does. Okay, so I'm just going to copy paste, and I'll explain the code for you in a second, what it's doing. It says, okay, set the starting point to 1, 1. Where's 1, 1? Right? Set the size of the rect to 10, 10. 10, 10. All right. Now, this doesn't care. All right. This does not care about the other image that's there. Okay. Next. Okay. So I want to get the size of the rect, and I want to get the context. Remember, I need to get the context. I need to say my CG graphics. Remember, there's a piece of code that we're missing where I want to say my context, right? So I want to say var context is equal to CG. You know, I want to get the context. Get CG context. There it is. From current context. Now this is from current image context. I want to get my graphics from current context. That's what I want to get. So what is the command? Do you think I remember? No. I can't remember offhand. But it's somewhere up here where we talked about getting the graphic context. Because we need to do that. Without the graphic context, we can't. Here it is. UI graphics get current context. So UI graphics. UI graphics current context. All right, so that's the context, right? So we get the current context, we set the starting point, and then we say the context now says incorrect argument label in call because in rect, it says how to fix that with in fix. Okay, if that makes sense. Some older code there. And it looks like the variable context never changes, so we can make this a let as well. That's what it's telling us to do. Okay, so we save that. And now let's see what it does. Size of the rect. Here's the rect itself. And we add an ellipse. What color is going to be the ellipse? We're going to talk about that in a second. We're going to set the stroke and all that stuff in a second. Let's try and run this thing and see if that's any different. Now, it should draw right up here because it doesn't care what's there. Even though there's an image there, it should draw a small little circle or something like that if we did it right. And if we're missing something, we can make it more apparent. Sometimes it's hard to see as well. The what? Yeah, but it's still generating. Isn't that funny that didn't end? There. Now it terminated, right? Isn't that funny? It took forever to give me that concat exception, right? Like forever and a day. It took like forever. You saw it before I did. All right, so what was the cause, right? We got an exception error, right? Now, a lot of times we can see what the problem is because right up here, it tells us what it is. It says, if you start reading the errors, and let's just get rid of this part because I don't care about this part, right? So sorry, my screen is really bothering me. So just, we'll do one of these. And it's hard because I'm projecting. So projecting is always more challenging than everything else. So it says core foundation, right? And we've got some, Objective-C dynamic lib through an exception. It says the core foundation, set value for key. So why do you think it did this? Okay, I deleted the outlet, and that's what caused it, right? Because I deleted it by hand, right? So let's go back. Could be. That's a good observation. And if for me to see that, if I click on this outlet and I go over here and I click on this, then we still have this outlet and I got to get rid of it. It's expecting an outlet and it doesn't exist. Very good. That's probably what it is. And let's try it again. Hopefully it won't give me an error. All right, no errors. I don't want any more errors. This is painful enough watching, right? Okay, so far, no errors. my friend, so far. Now there's an error. Okay, what's the error? So that wasn't the problem. And do I have a breakpoint? I don't think so. It says Q. I love these runtime errors. Oh, view control video. Okay, so why? This is interesting. So here's another question for you guys to consider, right? Is the view did load the right place for this to happen, right? So I'm kind of creating the context. I'm getting a graphics context, and when the view loads, do I have a context yet? And maybe not, right? Because nothing's loaded yet, right? So I don't have nothing to base it on, right? So that might be the problem. My problem might be, hey, I don't have a context. The unit view never loaded yet, and I have to wait for me to do this drawing stuff somewhere else. Okay, like I have to override the draw function and do it in there. Okay, because if I don't, then I can't get the context. So if I do override, right? I want to override the draw function, right? So I want to override the draw function. And no, I don't want to drop each. I want to override the function draw. Override, I'll be okay. Right? And if I do it properly, no, I don't want to draw the beach. I swear, I don't want to do it. Right? It says there's 3 accepted a parameter, but followed by, and I love when I don't get any kind of code hinting at all. But I want to create this draw function that does this work for me. Right? I don't want to draw it inside this context. It's wrong. Okay. What about if we skip through the PowerPoint? I'm kind of skipping through, and that's why it's happening. So I got this context. This is my graphic context that I'm doing. I'm doing all this stuff. Notice I created my stroke path. It's drawing the, I can set the stroke color as well. One thing we didn't do is we didn't set the stroke color or the width. So we can try doing this part, the stroke color and the stroke width, which we can do here. Notice it's based on the context. So I can do it at any time. So I can kind of do it over here if I want, right? Once I have the context, I can set the stroke color and the width. This is red. That's a pretty good color, and a stroke of 4, right? Again, it's not the right place to do it. View did load, not a great place to do it. Okay, and we talked about this. Now we have to go way back down here where we're doing this kind of stuff. And what I want to do is way in here. Okay, now this is interesting. So this is making its own color. Remember we talked about extension methods? I'm just trying to explain the PowerPoint so if you try it at home on your own. What the PowerPoint is doing is saying, okay, I want to add a random color function to my built-in UI color structure. Remember UI color's built-in structure? We're extending the UI structure by adding my own random color function to grab me uniform colors from 0 to 255 for CG float. 3 CG floats, red, green, blue. And I'm creating a new color, this new UI color, red, green, blue, and alpha being 1, meaning 100% opaque. That's what that is. So it creates a random color here. We don't need to do that in our context. I just want to make sure we can draw something. And it has some enumerations for different colors and for different shapes. So they have 2 enumerations that they want to try and get you to do. A line, a rectangle, an ellipse, and an image, right? And with different kinds of color values, my drawing color, whatever that is, right? Okay, cool. So here's the Quartz Fun view, and notice what they've done is they've created some shapes, and they created the current color. And now what they did was they got a reference to the image. Now they're doing it the other way around. They're doing, instead of using CG, core graphics, they're getting the context from the image like we did. Okay. And instead of getting a reference to the image by dragging and dropping and getting a outlet, they just got a reference by the name. Okay, that's what they did. Just a different way of getting the reference. Okay, I'm not going to keep going there. And this is the touches. So when you touch the image, they override the touches began with the events. I just want to find an example of where they do it with core graphics, which I know they have. Okay, here's my view controller, UI segment control. They get a reference, and somewhere down the line here, they're going to have an example of the code that I want to use. Okay, so here we go. So here they set, depending on which control you touch, they set the drawing color and to a certain value, depending on which control you're touching there. Okay. And they change the shape depending on the segment to control. Whatever you choose, they change the shape and the color. That's what's happening here. But we really want to add the drawing code, which is what we want for the most. And here's this override function draw. And notice that they say here's the CG rect, right? So I'm overriding the drawing function to do that. And I tried doing it. It gave me a bit of an error. That's only because sometimes what happens for me is and this is exactly what I want to do. Except for instead of doing random colors and random shapes, I'm going to do our own shape and color. But I need to override the draw function. So let's try it again. So I want to, instead of doing it in here, I want to go here and I want to override the draw function. Does it actually give it to me again? Of course it wouldn't. And it tells me it wants to override the draw function called beach. Okay, so I'm going to kind of do this. I don't want to override beach. I want to get something called rect, which is type CG rect. Okay, there we go. And what I want to do is I want to grab this context stuff, this thing here. I'm going to grab it and populate it in here. Now it says it doesn't override any method. Now, why would that be? Because where am I putting that? It says, so it says the view, right, and replace the commented out draw rect function method. But how does this work, right? Am I missing something to give me the ability to draw something, right? Because I mean I have an overloaded draw method, but how do I do it? Anybody have a recommendation? Method is not override. So am I missing some kind of UI view controller? Do I have to make it implement a certain thing to make that happen? Right? Well, a simple way to do it is I'm going to use my friend Google here for a second because I can't remember. I just can't. And I'm going to draw using Core Graphics by iOS 11. Right? Because at the end of the day, I just want to see it. I want to just get a snapshot of what to do, and then I'm good to go. And here it is. So function draw line, override function draw, but how are they doing that? Where is my current context? And that's what I wanted to see. I want the custom views initialized. Custom view, shape view. Oh, a subclass of UI view. Okay, that's different. That is not UI view controller. So I'm making my own class called of type UI view, right? And then that would give me my shape view, and it would allow me to create my draw. So my draw call would be on a particular shape that I'm adding into my code. So I'm curious, just to go down further, draw rectangle, draw circle. I think there is my view controller is going to be modified somewhere. So I got my button pressures, my IB action, and in my view controller, just to say, I'm using some random code here. Here's my function draw lines. Here's my function draw rectangle, and this is the exact same thing. There's the context, UI graphics, get current context. We did this, right? And they use a guard let, which means if I can't get a graphics contest, then do nothing. But I want to get a better example. This isn't a complete piece of code. This is only the code for the graphics object that I want. So drawing shapes. All right, so here's another one. Draw graphics, and I want to see the my override. Now this override draw function is the actual object. So there's my button, control drag. And they're doing the same thing. So they're creating actually a UI view, a custom UI view that they're getting the core graphics thing for. So my push button.swift. And what they're doing is they're making a custom control to add this draw function into. So draw, see if you guys can help me out, guys. Come on, I don't want to waste your time. if you all search at the same time, we'll find something much faster than if I'm searching on my own. And I just can't remember. Button. There's a custom button control, and that's why they're doing it. They're making their own custom control, and they're adding this control programmatically, and that's how the draw function is there, right? I mean, I guess it could get a reference to it. I guess I could get a reference to the object instead of getting a context. I could use the context that we're using already. So instead of this draw function, right, I could make a custom class, a UI view, a custom UI view that I add to the super view. So I have my custom UI view that adds to the super view and creates the shape for me. I think that's what it's doing, right? As opposed to the way I'm doing it here. Because that's what they're doing here. They're always creating a custom UI view as an example, and then that's how they're doing it. I was hoping there would be a simpler way, and I think there is. For the life of me, I cannot remember it. Well, I may have to do that. Graphics, gradients, and contexts. I just want to add it to, instead of a UI super. So I got some outlets. I got a container view and a graph view. And what am I doing here? I'm getting the IB action when it's clicked. I'm going to go to the UI view, and I'm changing the transition. I don't care about that. And then what I want to do is I want to create my own custom UI view. Yeah, so that's what they're doing. So they're making their own UI view called the circle or whatever, and then they're creating the gradient from there. Because they're calling it from inside their area. So I'm creating a new object. Okay, we can do that. I didn't want to do that, but that's fine. So what this is actually telling me to do is it's asking me to create my own UI view and add it to the super view, right? So whatever the view is, I want to take that view and I want to add a sub view. Remember like how it showed in our code, right? I just ignored them because I thought, hey, maybe I can just do it like this, but no. So I'm going to go and add a new file. We're going to make a new Swift file, right? So new Swift. And of course, this is going to be called something like I don't know, we'll make it an ellipse or some kind of rectangle. So ellipse. New. Create. And we'll make it so it's of type. I have to import that. I don't think so. I probably could have used another class, but let's just see what they did here. Really quickly, I don't think I need to. I think I just need to do one of these. Yeah, so a custom class. Now this is IB designable. I don't think I need to do that. I definitely need to do import UI kit. Import UI kit, and I'm gonna make a new class, right? Yeah, for sure. So I'm gonna do a new class called ellipse view, which is going to be of type UI view. And inside that, what I want to do is I want to override the draw function. I believe I need to have an init function, but let's just see. Maybe I do. That's like some kind of constructor, right? Let's go to my view controller here, and let's take this override. That's why I didn't find it, because it was like, hey, wait a minute. You're not doing things properly, Tom. And let's drag and drop it into this. Okay, there we go. So I'm overriding that, worked okay. So this is going to basically override the draw function. Now it's going to request a CG rect. So when I do the draw, I have to tell it where to draw. And just like it does here, where I override the CG rect, and I got my start color and end color here. I don't have to make it IB designable. I don't have to kind of crank it that way. And then it's the start point and end point. And pretty much that's what the draw function does. And I should be able to call it the draw function inside of my, now what do they call this thing? They called it, just to give you an example, graph view. And I want to add the graph view to my to my view, my view controller. Graph view. Where do they do it in the view controller? So where's my view controller? Context states. I don't care about that. I'm not making a Bezier path. And there's the context. This is inside the view. I don't have to do it that way. I'm pretty sure that they did it at the top when they set up their view controller. Bear with me here. And where do they do it? Gradient? No, so they don't show it here. GraphView.swift. But I don't care about that. I want to call my view controller. And I want to use my graph view in there in this case. So my draw function, I could do that green button. But I need to call the view controller function. It's my push button. And unfortunately, they don't show the view controllers, so I'm going to have to guess. 5 pixels in straight lines. It's actually a really good tutorial, it looks like. But they don't show the view controller at all. They show this custom view. Right? Here's the push button. The push button is a view, a UI view of a type. Right? And then here's the counter view with the overwritten object, but it really doesn't show me the view controller, which I'm hoping it would. But of course it wouldn't. And there's my view controller, my counter view, and it's not going to show it. Okay, so let's just add and let's try this out. So I'm going to go to my view controller.swift, and inside my view did load, I'm going to say something like, I'm going to let my new ellipse view, ellipse, right? I want to make it an ellipse view. Ellipse view. Ellipse view. There it is. Okay, so I want to do that. So my ellipse is equal to an ellipse view. And what I want to do is I want to say that my super view, I want to add my add subview, my ellipse. See if that's good enough. May not be good enough. But let's see what happens. Whoop. Errors. I cannot convert type ellipse view type to expected argument of UI view. I guess I can say as, does it have a fix for me? Expected constructor call after the name. Yeah, of course. And that would do that. I was just rushing it, and that should do it because that becomes a UI view, and that should cover everything. Let's try that out now. And that's inside the view did load. So after the view loads, I make an ellipse happen by creating an ellipse object, which I declared as a view, but I'm missing my initializer. It should be able to do it anyway. And it didn't do a goddamn thing. But it didn't fail, which is a good that's a good thing. Right? I don't see it. And let's make sure that it's not nowhere weird, because that didn't do the cut. Let me just get rid of this just to check it. I'm going to go to my storyboard, and in my main storyboard, I'm going to get rid of my objects just to make sure there's nothing there. And let's run that again. I think it did that earlier. Yeah, it might be there, but I can't see it. I don't see a damn thing. So that didn't work. Interestingly enough, it should still show the view. If I added a view, it should still show it in real time, right? So it looks like it didn't like what I did. Anyways, the idea is that you create a view. I'm not going to go through it. It's 1025. I can go and fix it. I know that's probably something close to what I have to do. But the idea is that you create a context. In this particular case, I'm making a new context. And then the UI view is what I'm adding in. And the UI view should draw inside of our viewport. And our view, if I clicked on view dot draw, what I'm telling you to do is take the context that I have, this view itself, and use that to add to the super view. Now I could make a reference to another object and add it inside of that. So if I was to undo this object, okay, if I was to undo this object, this beach object, and instead of adding a subview to the view, I wonder if that would work. And then I'll let you guys go. I could make a reference to the beach again, just like we did last time. And then when I make that IB outlet, once I have a reference to the beach image, so control drag into the, here, I'll call this beach image. Class name controller. Yeah, because I'm putting it in the wrong place. Let's just continue. Sorry, I've got no room and I can't see what I'm doing. So I need to put this in here. A UI image view, and we'll call it beach. Why? Could not find a class name view controller in the language Swift. What was that? Did I do something wrong? Where? Oh. UI view controller. Oh, core graphics. What the hell? Oh no, it's the right file. I've deleted some stuff. Deleted. Yeah, no, but why? Interface. Oh God. Yeah. So manual. View controller Swift. That is weird. I forget when it does that, and it does that quite often to me because I just don't pay attention. Okay, so let's try this. We'll say beach view. Beach view. And if we did the beach view, then we should be able to, instead of adding it into the view, we'll say to the beach view add subview ellipse. And that should be the same. I don't think it's going to work because we're missing something. But that should make a subview inside the beach view. And then draw the red image, and it does not. I can't see it. Yeah, so it's not drawing, or either that or I'm not referencing the object property. But anyways, you get the idea. The idea is you add a subview, and then you can draw whatever object you want. I'm just skipping through a bunch of lines. One thing I could do, and I'll have this for you next time, is for people who care, right? This is the thing, for the people that care. I have a bunch of example code, right? So most likely it's inside there somewhere. And I'm wondering if I have it inside of my instructor resources because I have all my code. Let's go back to my last week's thing that I got. Give me a second here. Yep, and it's somewhere down in here. No. I think it's something like 17. Like shooter, no, that's way, way out there. 17, 15, 16. Port's fun, here it is. So yeah, great thing is I can always check it and see what the hell I did wrong compared to this one. That's a really nice thing from having example code. Yeah, so I have this, my view controller, and I create an IB action for changing the color based on me pressing the button, which is totally cool. It's got lots of errors because it's old Swift, but in the Quartz view application, I have this random color that they tried to create, shape and a drawing color, and then a new class. So a couple of things here. We have an extension that we put inside here. Here's my Quartz view fun, my UI view. Just began, which I don't care about right now in our context, or end, and then there's a draw function, and we don't really care about it. So we did things correctly. We did things correctly. I don't think this is wrong what we did, but now when we map to it from our view controller, we have to select our Quartz fun. the fun view, right? Because that creates a, here it is. This is different. So we did it differently. We did it, so let fun view is equal to view as a quartz fun view, which is one of these. So we kind of defined it wrong, and then we said fun view dot shape is equal to shape. Shape meaning the shape selection, whatever the shape is, and then we're saying, well, you know, shape is equal to shape image. But this is pretty much this is using an IB action, some kind of shape change, which I don't really care about. I should be able to do it the way we did it. It's just that in our, they're doing it this way. So the way we did it, was slightly different. Anyways, guys, thank you so much for sticking around. I'm not going to keep you much longer. I'm going to finish this and put it up on GitHub, right? But you guys can go. So remember that next week, before we leave, there's going to be lab number 1, which I want to see your design for your slot machine. Okay, that's what I want to see. Okay, so please have your partners. I know some of you are already partners with different people. Again, you can have up to 3. If you decide to have only 2 is okay. I don't recommend 1. Please don't choose a single person. And if there's someone missing, I see some people missing today in class, maybe they're sick or away or whatever, please make sure you connect with your partners from before, because I don't want anyone missing out, okay? Otherwise, that's it for me, guys. I'm going to stop recording this, and I'll fix it, and I'll put it up on GitHub, okay? So I'll see you next week. All right, thanks.